My name's Katie Atkinson. I'm a reader in the Department of Computer Science here at Liverpool. So I came into computer science via a bit of a strange route. So my A-levels are actually in arts subjects. I had a place secured at university after my A-levels to go on and study languages. I took 2 years out after that to sit and have a think about what I really wanted to do. Did a little bit of lying on a beach, but don't tell your admissions tutor that if you take your 2 years out. And I realised that that wasn't what I was passionate about. And I thought I really wanted to go and study science. So I gave up my place to study arts subjects, and I came to the University of Liverpool to study for a bachelor's degree in computer information systems. I enjoyed it so much I stayed here to do a PhD, and I did that in artificial intelligence. And then after that, I liked the department and the city so much that I stayed here, and I'm now on the academic staff. So when I did my bachelor's degree, how did I decide that I wanted to focus on artificial intelligence? Well, as many of you may know, artificial intelligence has been referenced a lot in popular literature, popular culture. I've borrowed the title of my talk from a very famous science fiction book called Do Androids Dream of Electric Sheep that was later made into the well-known film Blade Runner. So this film and the book are all about androids that are being built, and it's a dystopian future where they come and they take over the world, and Harrison Ford has to try and stop this happening. Okay, so people know a lot about artificial intelligence from science fiction, and it's a great opening line if ever you're at a networking event or at a party and you tell people, you work in artificial intelligence. And then within 5 minutes, people are often quite interested, but the inevitable question comes up, when are we going to get to this situation here, and what are you going to do to try and stop that? Okay, so Terminator up there, iRobot, another film there. So this has really given artificial intelligence a bad name, all these dystopian films. So I'd like to try and tell you a little bit today about my perception of what artificial intelligence is and what artificial intelligence researchers are currently working on. Okay, so these two images here really represent the notion of trying to produce a general intelligent being, and that's what people fear. They want to know when the robots are coming to take over. It turns out it's actually very hard to replicate a general, all-purpose, intelligent human being. People really started ramping up work on AI in the 1950s and 1960s, and when it turned out that even simple problems were difficult to solve, then there was a shift in the focus of AI, and people moved away from trying to build an all-purpose general intelligent machine and instead tried to build machines that were very good at doing specific tasks in specific domains. Okay, so what I think AI looks like is actually something like this. So this is a very famous machine called Deep Blue that was built by IBM, and in 1997 this machine competed in a chess tournament with the world human champion Garry Kasparov, and Deep Blue won that match. So there were a number of matches played, and Deep Blue came out as the overall winner. Garry Kasparov did talk about the IBM programmers altering Deep Blue as play was going on, but it's seen as Deep Blue won that particular match. Okay, so another very popular application area is something called RoboCup. So every year there's an annual competition. The ultimate goal is to try and build a set of robots that will ultimately be able to play and beat a human team at football. We're a long way off that now. If you just do a search on Google and YouTube for some videos of this, you'll see where we're at. Okay, that looks quite impressive, but you should see what happens next. But this is not just about the fun of trying to build robots that play football. There are actually some serious issues underlying this. So how do we do teamwork? How do we do cooperation? How do we do communication and forward thinking and problem solving in these intelligent agents? Okay, so some more application areas. Probably the most popular one that people know about that makes use of AI technology is driverless cars. Researchers have been working on this in universities for a couple of decades now. Google have taken it on board and produced their version of a driverless car. There are all sorts of technological challenges. There are legal and ethical challenges as well. So who's responsible if something goes wrong with the car? Is it Google? Is it the programmer? Is it the stupid human who caused the crash in the first place rather than the nice, safe, autonomous car? Another example, planetary rovers. So the European Space Agency is working in 2018 on sending a rover up to Mars. Here's an example prototype. of that. So we want these rovers to go up and to be able to explore their terrain autonomously, go and find rock samples, and do a bunch of other tasks that the scientists want to find more information out about. Another application that some of my colleagues in computer science are working on, so it's not the scary Terminator scenarios. Robots can be nice, so they can help old ladies to remember to take their medicine, and this is a genuine scenario that is being worked on today. So here's the carer bot. So you've got somebody who is reliant on assistance around their home. Could we get a computer to remind somebody to take their medicine, bring the medicine over to them, and do all sorts of other helpful things as well. Okay, so that's AI in general, and there are lots of very interesting, deep philosophical questions that are posed in books like Philip K. Dick's and also in the Terminator and Blade Runner films and all films of that ilk. So what does it mean to be human? How do we define intelligence? How do we stop the robots taking over? But what I'm trying to show you is that we're actually focusing on specific domains where we can make use of AI. So that's AI in general. My particular research is focused around something called computational argumentation. And what I'm most interested in is how we can describe in a machine understandable language, so that we could then turn it into a computer program, how humans actually argue. So lots of people see argumentation as a negative thing. I see it as a good thing. It's how we make decisions. It's how we justify what we believe, and it's how we justify the decisions that we make. We require politicians to do it. We require people to do it in all walks of life to get on with our daily life. So you say to your robot, where should I go for dinner tonight? It will come up with a variety of different arguments about what is best for you to do, and it might base that on a number of different criteria, objective things like whether a particular restaurant's open, how far away it is, and it might also be based on subjective information such as which particular type of food you prefer, whether you're going with some friends who prefer a different type of food. So another particular domain that I apply in my work in argumentation is artificial intelligence and law. So I'm interested in trying to develop tools that can make use of computational argumentation to reason and argue like an expert, such as a lawyer. So I've applied my work in legal applications. I work with a legal firm as well. And one particular piece of work I've done, we've looked at some legal cases. A particular one was involving a dispute over who owned a baseball that was hit into a crowd in a baseball match in the United States. And we take the decisions that the judges make, and we can break that down to the specific arguments that are made, because that's what lawyers do. They look at the arguments. Should we decide for the plaintiff? Should we decide for the defendant? We can look at those arguments. We can evaluate which are the winning and which are the losing ones, and we can turn that into a program, and we could have a decision support system for lawyers. Not necessarily trying to replace the expert and the lawyers, but trying to support them by doing fast and consistent reasoning. Okay, and I've done some work that's shown how we can indeed replicate in a machine understandable format the decisions that are made in cases like this. Another area that I'm interested in is something called e-democracy. So I want to know whether we can improve participatory democracy, so getting people to interact with democratic reasoning and processes and policy making through intelligent tools that make use of argumentation. Should we raise taxes? Should we prioritise funding on the Large Hadron Collider or on developing a robot that's going to help in care homes? Okay, so all those decisions need justifications. They need to be articulated. So that's another area where I apply my work, is to try and use argumentation to justify proposals for policies. Okay, so I'll make some small effort to try and answer the question that I posed and borrowed from Philip K. Dick in the title of my talk. So what does this computer scientist dream of? Okay, well, at some point in the future, imagine that here's my boss who comes into work one day, and there's a robot working in my lab as well. And my boss looks around and my boss says, "Hi, university bot, do you know where Katie is today?" And my bot replies, "She's at home finishing her Nobel Prize-winning research paper whilst I tidy her office and organise her diary." So I'll leave you to think about whether that dream would coincide with that robot's and whether indeed robots could ever dream. But that's it from me. Thank you very much.